For the honeybee, wax is an excruciatingly expensive biomaterial. They must burn through massive payloads of nectar just to secrete a single drop. The ultimate engineering dilemma: how do you construct maximum storage capacity using minimum structural material? If you build circles, you get catastrophic structural gaps. If you use triangles or squares, the partition walls demand too much surface area and become dangerously resource-heavy. Nature, ruthlessly efficient, selected the perfect hexagon. For millennia, humanity second-guessed whether this was truly the ultimate geometric architecture. It wasn't until 1999 that mathematician Thomas Hales finally cracked the Honeycomb Conjecture. The geometric optimization algorithm proved that the perimeter of a hexagonal grid with an area of 1 is permanently locked at a hard lower limit, 2 times the fourth root of 12. No other shape in the universe can conserve more material than this exact threshold. Honeybees don't need to study geometry, they are born as the living embodiment of absolute optimization. Storage secured. Now initiate the navigation protocol. When a scout bee locks onto a floral payload, it returns to the hive and executes a waggle dance, uploading targeting coordinates to the swarm. This transmission encodes 2 critical variables. Nearly 2 seconds of waggling equals roughly 0.62 miles of distance, and the angle of the dance perfectly mirrors the flight trajectory relative to the sun. This masterclass in multivariable problem-solving directly inspired computer scientists to engineer the Artificial Bee Colony (ABC) algorithm, a powerhouse sequence now deployed to optimize hypercomplex digital networks. But there is a massive system glitch. The hive interior is pitch black, and the solar tracking target is constantly shifting at variable speeds across the sky. To bypass this, the bees execute a genius coordinate system hack. They use the downward vector of gravity as a surrogate for the sun. Simultaneously, their bioprocessors run a real-time compensation algorithm, continuously calculating and adding the sun's invisible orbital shift outside. Even more epic, this system is hardwired to patch any experiential blind spots. If a rookie drone has only ever witnessed an afternoon sunset, it intrinsically knows exactly where the dawn will break. Zero visual confirmation required. Its brain automatically executes a step function, adding exactly 180 degrees to the dusk vector to perfectly interpolate the sunrise coordinates. It is a biological machine running continuous GPS updates without ever needing to look at the sky. Locking onto a heading isn't enough, the swarm must know the exact breaking point. Bees deploy a mechanism known as optical flow. When a bee launches, it doesn't measure distance with a biological yardstick, it calculates the angular velocity of the landscape blurring past its eyes. Their neural mainframe is calibrated to an absolute constant. Every 17.7 degrees of visual shift across the retina is encoded into exactly 1 millisecond of waggle dance data upon return. A flawless integral calculus of distance. Yet, this bio-odometer harbors 2 fatal blind spots. The first is spatial distortion. In one experiment, scientists launched bees through a vertically striped tunnel spanning a mere 20 feet. The extreme proximity of the walls caused the optical flow to hyperaccelerate across their retinas. The aftermath? The scout returned to base reporting a grueling flight of over 610 feet, roughly the length of 2 full football fields. The claustrophobic visual illusion had amplified the perceived distance inside its brain by exactly 31 times. The second is a critical contrast vulnerability. The bee's internal tracker only stabilizes when environmental contrast stays above 20%. When cruising over glassy lakes, where contrast plummets to a dismal 9%, the algorithm completely collapses. The optical clock in their eyes throttles down, running 3 to 4 times slower. A massive, long-haul flight over water gets logged as a short hop, feeding corrupted telemetry to the worker swarm and sending them wildly off course. Millions of years of brutal evolutionary research and development inside a tiny, buzzing insect. Turns out, It's the ultimate master blueprint for humanity's most cutting-edge tech.